Hi, my name is Saxon Omdahl. I'm a technical fellow at F5, and this is an introduction to generative AI. I'm not going to get into sort of the weeds, really detailed nuts and bolts on generative AI. This is more of a high-level overview of the technology, where it's going, and considerations, particularly those that are relevant to Greenhouse. This is what I plan to cover. So, a little history around generative AI, a closer look at ChatGPT and GPT-4, a large language model architecture, not in detail, but high level, the salient points that are good to understand when working with language models, generative AI security, and finally, I'll touch on some opportunities. Sorry, so many Zoom controls are actually covering my screen. There we go. So generative AI has been generating a huge amount of excitement across the industry. And a lot of people have come out and made statements about AI, some very cautionary, some about all the marvels and wonders that it will bring. I align with statements like AI will be the biggest thing this decade. I completely agree with Bill Gates on that. That we are just seeing the beginning of generative AI technologies, and already it's clear that they're going to have a massive impact on almost everyone's day-to-day roles and operations. Other cautions like humans must be unambiguously, unquestionably in charge of powerful AI models to prevent them from going out of control. This is also true, both from the perspective of AI models literally going out of control and just doing bad things because the software isn't well behaved, but also even well-behaved software can have unintended consequences. And so we really do need to keep humans in the loop to make sure that it's actually serving our needs and not just making large but potentially negative impact in the world. So if you look at the rise of generative AI, it absolutely has been an incredibly rapid revolution. So just looking at the bottom right chart, you can see the amount of time it took to reach 100 million users. And so there on Netflix, you can see it took, over 3,500 days to get to 100 million users. Google Translate was faster, Instagram faster, but ChatGPT basically has destroyed all benchmarks in terms of user adoption rates. And everyone who uses it is kind of left with a sense of awe, sometimes fear. A lot of people trying to figure out how to use this for their job or to create new products. And you'll see this later on as I get into the evolution of the technology. But there is a massive amount of focus on this technology, not just within technology companies, but pretty much within all companies, even your mainstream consumer brand companies. They are heavily invested and focused on technologies like this and trying to find ways that can optimize their business. In 2022, Sequoia predicted that text and code generation would be ready for use in 2023. I think text is definitely there for some purposes. I agree with them on code. I think their estimates on image, video, and 3D modeling are actually too far out. For some purposes, images are just fine. And video is already advancing, although a lot of the videos that it produces are very strange and you might say artsy. But I don't think 3D modeling will take that long to advance, as long as the industry actually focuses on it. And it appears that the industry has not been focusing very much on 3D modeling, but that seems like a much more tractable problem to me. You're also seeing generative AI adopted by tools across all industries. Everyone's trying to figure out how to embed help, recommendation, other types of functionality inside of their applications. And I would expect this to persist for the next several years at an incredibly rapid pace. And of course, some companies are going to get it wrong, and we'll get to sort of suffer along with them if it's one of our favorite tools. But it's going to disrupt industry pretty much at all levels and all ways of working. Now, looking at the bottom left, in terms of online generative AI content, it is rapidly taking over the content online. This is not surprising. I've already seen a number of posts related to capturing various keywords by generating a massive number of web pages around a topic, and then using that as sort of a search engine optimization approach to capture all of the queries for these given terms, and then using that to sort of monetize that by way of ads. And so it would not surprise me that by 2026 we may see 90% of all online content being AI generated. That doesn't necessarily mean that the content you want to see will be AI generated. It just means that by volume, there will be people out there creating a massive amount of AI generated content in an attempt to capture eyeballs. So how did we get here? Well, despite the sort of exponential growth, rapid rise charts I just showed you, it actually has been a very long journey, and it has been a journey with a lot of different turns, and you might say dead ends, but you could say different paths being pursued towards artificial intelligence. In the beginning, you have things like k-means clustering and genetic programming, and around up until the early 90s, neural networks weren't really functional things. The alternatives to neural networks largely outperformed them, and this is due to software advances that have happened after that point, as well as hardware advances that allowed larger models, much faster execution, and the like. But as you get into the 2000s and later, neural networks really start to take off, and in 2020 OpenAI launches, and from there you can see there's a massive move towards neural networks and transformer architecture. So what are these other technologies? And I think it's important to understand the other AI technologies, because generative AI is not just a better version of AI. It's a specific version of AI. And it is the right tool for many applications, but it is not necessarily the right tool for every application. And so in looking at AI technologies, they can sort of broadly be categorized as three different things. You've got unsupervised discriminative technologies. You've got supervised discriminative technologies. And discriminative in this case means that it makes decisions or classifies rather than producing content. And then you have deep learning generative AI. And the topic that we're discussing here today is the deep learning generative AI technology. But in the context of greenhouse projects, it's important to understand these other technologies, because sometimes they may be the right tool for the job. So these unsupervised discriminative technologies are very low cost classifiers. And I say low cost because it's not just in terms of execution time, but it's also in terms of the amount of data involved, the training, potentially even the maintenance of the code, and certainly the execution of the code generally is much lower cost for those technologies. And we can see that in DDoS mitigation. Our shape technologies kind of fall into this green category, and they're great for threat detection and analysis. And they require more training, more care and feeding, more data, but they're capable of making better decisions in a lot of cases than the unsupervised discriminative technologies. So, and what's interesting is that when you have all of these together, you can kind of disrupt this paradigm in product development, which kind of focus you on building either a low capability but easy to use system, or a powerful system that's very complex. Using all of these technologies together, you can actually build a very powerful system that is not very complicated to use. And largely that's unlocked by these generative technologies and their ability to generate configuration from very simple input. So as I mentioned, generative AI describes algorithms that can be used to create new content. So that could be text, images, video, 3D models. And on the right-hand side, you can see that there's actually a very large number of companies in different spaces involved in generative AI. It's not all ChatGPT, OpenAI, although they dominate a large number of different sort of sections of the space, from code generation to text generation and the like. And this presentation will be available afterwards. What's kind of interesting about it also is you can see some of the models that are used in these different domains. So if you want to look at a domain other than text generation, this slide may be helpful in terms of getting some starting points about where to look. So in terms of architecture, there isn't actually a single architecture for generative AI. There's generative adversarial networks, variational autoencoders, and the most common, though, is the transformer network. You can see something like variational autoencoders inside of Stable Diffusion, and they're used for things like adjusting the final colors of an output image. But most of what you'll work with most likely is going to be transformer based. And so OpenAI is focused on transformers, and GitHub Copilot is a partnership between GitHub and OpenAI for code generation. And so I don't know if any of you have used Copilot, but it allows you to sort of get sort of auto completion or recommendations on code. Now, there are, of course, a lot of challenges with this approach. It was trained on GitHub code, not GitHub's code, but code that was in GitHub. And so there's risk of plagiarism and copyright infringement. The generated code doesn't necessarily always compile. That's fairly easy to detect, but even worse, it might not always do exactly what you want. And there are potentially a number of security flaws in the code that it generates. And this is because of the way that transformers generate output, which I'll get into later. But these are inherent kind of challenges with the architecture behind Copilot. So something all of you are much more familiar with, ChatGPT. This was launched in November of 2022. So kind of amazing how recent that date is, considering its popularity and the number of iterations that have occurred and new features that have been released. But right now you have access to either GPT 3.5 models or GPT-4 if you're a paying customer. And GPT stands for Generative Pre-trained Transformer. So generative, it produces output like text and images. Pre-trained, which means it was trained before you use it, so you can just start interacting with it and having it generate content. And of course, it's transformer based. And if you haven't used it, it of course lets you generate a text skeleton to describe a concept. You can use it to outline a presentation for you. You can use it to summarize text, generate, content, text-based, translate text. It's actually fairly good at a few languages, although not every language. But there are a number of risks with it. It's not uncommon for it to produce incorrect answers, and you can't find out where the source of its answers came from. So when it gives you an answer, there's no real sourcing of material. And if you ask it for sources, it may create sources, but that doesn't necessarily mean that those are actually the sources. They're just sources that it says that it has provided. And it has both unintentional and intentional bias in its answers, which I'll get into later as well. So the most recent model they've released is GPT-4, and in fact, OpenAI has kind of made statements that they're not looking at releasing a GPT-4.5 or a GPT-5 anytime soon. And I don't find this surprising based on sort of the next set of areas that they would need to optimize. It is based on the same data set, the 2021 data set available to paying users. The big deal with GPT-4 is, in my opinion, the 32,000 tokens for context. So tokens are having this many tokens is critical for getting the language model enough information that it can generate useful output. And also having that many tokens available means that it's able to produce a much longer output for you. It's multimodal, it can describe images and interpret the text inside of an image. And in theory, it can translate a UI sketch into an HTML5 and JavaScript page. I haven't been able to get it to do that, But in theory, that's one of the things it's able to do. And it's better behaved at calculation, mathematical reasoning as well. And GPT-4 is also where OpenAI started integrating with partners. So they integrated with Duolingo, Dropbox, Stripe, and other companies as part of developing their solution. And this is really part of a move from being just a language model to being an augmented language model. And you can see sort of a very large movement towards this with the release of GPT-4 plugins. So what a plugin is it's an API call to an external service from OpenAI. So when you enable a plugin in ChatGPT, it will call out to external services. And these external services can retrieve data. They can perform various actions like booking a flight, making reservations. They can perform calculations if you enable something like Wolfram or Code Interpreter. So the idea is that the ChatGPT system is no longer just the language model that you're directly interacting with via a prompt. You now have integration with external systems that can augment that prompt by providing additional data, or can take action based on your prompt or the response back from ChatGPT and do things like I said, with Expedia, booking a flight, making reservations, booking via Kayak, etc. I checked this morning, it looked like 569 plugins available today, which is fairly astonishing considering this launched not that long ago. And in fact, when I had first made these slides, it was 440. So it appears that the rate of plugin development is actually increasing. But plugins are a pretty interesting way to extend ChatGPT. So some cautions and guidance, of course. ChatGPT at F5 is approved for the limited purposes of enabling ideation and as a resource for relevant sources of information. Do not upload confidential information. So no proprietary F5 information should be sent to ChatGPT or any of the OpenAI APIs. No PII. No confidential information of any sort should be sent to that service. This is not an endorsement to use ChatGPT or similar services for your work. So despite all these capabilities, I'm not actually endorsing you use them for your work. If you use ChatGPT, you should opt out of data collection. And here's a little blurb. When you use your non-API consumer services, ChatGPT or DALL-E, we may use the data, blah, blah, blah. This is from ChatGPT. So here's an opt-out link. So you can opt out from data collection. And finally, the security, IP, privacy, and ML governance teams are working to get other services and tools approved for all F5ers. This is in progress, and hopefully we'll hear more from them soon. That said, I have used ChatGPT to do some things, one of which was generating a marketing email, which was not sent out, just a test, from a big IP SSL orchestrator datasheet. And that's public information, that's not PII. And I asked it to write an email with the following prompt. You're writing a marketing campaign email for F5. The email will be sent to application owners in the financial industry. Use the information below to write a short and compelling sales pitch for a big IP SSLO orchestrator. Limit the email to 250 words or less. Use bullet points to outline key capabilities or use cases. Return only the main response. Remove pretext and post-ends. So you can see I actually gave it more than just asking it to write the campaign email. I gave it some hints about the format I wanted and the length and things like that. Now be aware that when you ask it for a certain length, it often doesn't understand exactly what that means. So you might be making the response longer or shorter, but this 250 word limit is not a hard limit. And on the right, you can see the output. I'm not going to read that all to you, but from my perspective, this was a reasonable first pass at a campaign email. It uses bullet points. It highlights some key capabilities. And it seems like with a little bit of editing, this would be good to go. And it would have, if I was writing, campaign emails like this would have saved me a fair amount of time. I also asked it if it could write an I rule. I asked it to write an IRL to set a cookie, and HTTP response whose value is the server pool member plus the current time plus a salt, encrypt the cookie. So not an entirely basic IRL, but fairly straightforward. And what it gave me on the right, while I haven't run it yet, at first glance, looked close, if not correct. And part of the reason why I think it has such good performance with the IRLs is that it was able to index Dev Central, and on Dev Central, there's a lot of IRLs examples with human readable text next to the IRL. So there's a lot of context around what the code does. And so this enables it to generate quality IRLs. Had there just been a list of function definitions for IRLs, like a language spec, but without any code examples, with no comments, etc., it would not have been able to perform this task. So I was actually happily surprised by what it produced. But you have to be very careful about what you send in your prompt to language models. The details really matter. And here are two examples that are pretty similar, but the slight differences in the input prompt change it from giving a completely incorrect, bizarre answer to a reasonable answer. So on the left, I'm asking it, when I was 4 years old, I was 102 centimeters tall. When I was 8 years old, I was 127 centimeters tall. I'm now 64 years old. How tall am I? And without any more information than that, it essentially does a linear extrapolation and determines that I'm 4.75 meters tall at 65, which is at best highly unlikely. When I give it like height percentile information inside that same prompt, telling it that 102 centimeters is 50th percentile for height at that age, and 127 is 50th percentile for height at that age, right? That's all the real additional information I'm adding to that prompt. It suddenly comes up with a fairly reasonable response, right? It understands, height percentiles, and now it says I'm 169 centimeters tall, which is a reasonable height for a human. And so you have to be very careful about what you put in your prompts. And this is part of the reason why it doesn't surprise me that OpenAI has kind of paused a bit on the language model development side and focused more on the plugin augmentation side. The barriers that they're running into right now are generally easiest resolved through integrations with data sources and external systems that can perform calculations and things like that, and are not as easily addressed by iterating on language models, trying to increase the size of their data set and the like. So what can you do with different prompt formulations? Well, you can guide thought. So you can say, provide a thorough and in-depth analysis of the subject matter, or break down complex concepts into easy to understand frameworks and models. You can change output style, right? This last one is one of my favorites for writing marketing type blurbs. You can say, use short, pithy sentences that pack a punch, right? Or you can say to end with a sentence like that. You can change the output format. You can also have it write in the specific style of an author or a book series. And that's very useful for tailoring the feel of the message closer to what you're looking for. And finally, there's a tendency for it to write way too much in its output. And that's because it was actually trained to generate long and large output. And so via prompting, you can actually kind of steer it back towards shorter, more concise answers. Around the time period of GPT 3.5, I kind of did an analysis of a number of different use cases. And unsurprisingly, the text generation tests all were, I thought, very, very high quality. The output was usable. And so for text generation, enhancement, summary, outlining, sentiment analysis, I was very happy with the performance. But once I started to get into code generation, all of a sudden it didn't really work so well. And I'm still not really happy with the performance, particularly when the code is complex or involves marshaling data between multiple different formats or languages, I find that it doesn't really make anything easier for me personally. But for code analysis, it seemed to do a fairly good job. For comment generation, it did a good job, but there's a real caution around that. And that is that if you ask it to add comments to a body of code, you have to be very careful with what's returned if it includes code, right? So if you ask it to insert comments inline. And the reason for that is that it does not necessarily respect your code when you ask it to add comments. It might add comments that are appropriate for your code, but it might also subtly alter your code. And of course, that's not good behavior when you're asking it just to insert a comment. And that kind of a problem is something that's a lot easier for a tool like Copilot to work around, because they can constrain the region that the language model is able to edit. But just using ChatGPT or OpenAI APIs directly for code generation and like inserting comments in bodies of code, you have to be very careful about how you go about that. So let's look at language model architecture. So what is a large language model? Well, at the core of a large language model is prediction. And what it is doing is it is predicting either the next word or words between two or more other words. And I say words, but in reality, it's going to be tokens, and I get into tokens later. And when it's generating these predictions about what best completes the sentence or what best fills in the gap, it is able to generate an array of different possibilities, each one with a probability. And using a concept of temperature, it selects which one it will use at that point in time to complete the sentence or fill in the gap. And what temperature does is it controls how important the weighted probabilities of those outputs are. So if you have a very high temperature, it is more random. And the fact that one word, like in this bottom right example, where hot is a highly probable next word, a high temperature example would kind of disregard hot, high probability, and would be biased more towards selecting the other answers. Whereas if you turn temperature way down, you're going to be much more controlled by the probabilities here. And if you turn temperature all the way down, in theory, you should just get the number one result. But in all of this, it's important to understand that the language model doesn't know anything other than these next word or fill in the blank completion things, right? It doesn't know facts. And as a result, it will tend to hallucinate. And what hallucinate means is it will produce output almost from nothing that is not factual, but appears coherent. And that's because it's generating valid sentences that seem probable. But inside of the language model, it's not like there's a database of facts, so to speak, that it relies on. Instead, it's going on probabilities. And these probabilities may steer it towards incorrect answers. And this could be in part from the data that it was used to generate it. It was generated off of data from the internet, which of course can include incorrect facts. But also it's not really operating off the concept of facts and logic in the first place. It's operating off of probabilities and frequencies and the like. And so if you ask it factual questions, it might actually generate a correct answer, but it might not. So that's something to be careful about. But if you're not looking at factual output, if you're looking at interesting output, from my perspective, it's already an incredibly powerful tool. So if you were to use this for writing fiction, it's already there and ready to use from my perspective. But as soon as you start needing it for generating factual output, you need to be a little careful with how you use a language model. So as I mentioned, it doesn't really operate on words, it operates on tokens. And tokens are a sequence of characters which may or may not map to a word. On the bottom right, you can see how a number of words or phrases have been broken out into tokens. And you can see that things like the comma counts as a token, but the space before a word is included in the word. Now, what's important to understand about this is that OpenAI charges you for each one of these tokens, both on the input and output side. So if you're writing an integration or anything that's going to interact with OpenAI, be very aware of the format that you're using because it will heavily influence your billing, right? So for instance, the section you see Unicode characters like emojis may be split into many tokens, right? And then you can see all those different sort of diamond question marks. Each one is another token. You get billed for each one of those. Similarly, you can see that all the punctuation tends to be a standalone token. So the data formats that you choose for exchanging data with OpenAI and with other systems that happen to pass through OpenAI, all of those will influence the billing of the system that you build. So as I mentioned, most of these technologies, the OpenAI GPTs included, are built upon the transformer architecture. The transformer architecture was developed at Google and is an alternative to the recurrent neural network. And if I were to sort of try to point out the most important change, in my opinion, I would say it's the ability to process the entire input all at once using positional encoding. So rather than consuming information a single token at a time, and each time running that token through the entire neural network, instead, a large amount of input can be consumed in a single pass by encoding the position of each token as it's presented to the system. And in this way, it operates much faster than previous neural networks. And because it operates so much faster, they're able to encode and process much larger data sets, which in turn drives performance of the model. And so this is one of the reasons why the transformer architecture has kind of exploded onto the scene and really changed how these generative AI technologies are built, is because the performance is massively better than many of the other approaches that were used. So as I mentioned also, ChatGPT is biased intentionally. It is biased against offensive output, biased towards verbose responses, and biased against hallucination. That's not to say it will not hallucinate, but in the training of the model, they attempted to reduce the amount of hallucination that occurs. And these biases are built into the language model itself, and they're encoded in the neural network weights. But you can counteract the biases, or at least kind of bias in the opposite direction, by writing certain types of prompts. So even though the model is biased against offensive output, given certain inputs, you can activate the neural network in a way that offensive output will be returned. So this is not a complete pruning of the ability to generate certain kinds of concepts, but rather a biasing against it. And ChatGPT itself, so not the APIs, but ChatGPT is also likely modifying whatever you prompt it with every single iteration. So they're likely, doing history management. So when you ask it about a previous message that you'd sent, that is context inside the prompt that you send at that point in time. It is in some ways auto-selecting the language model to apply, and it's unclear what other business logic they may be applying. And of course, it's altered if you've enabled any of the GPT plugins, because those themselves are inserting data and modifying the responses. But here you can see on the right the kinds of tests and tuning that they performed. So real toxicity is trying to tune it against offensive output. The API data set and tuning it against hallucination. And the truthful QA trying to, once again, sort of tuning it against hallucination, but towards useful output. If you are looking at using other language models, not the OpenAI ones. One thing to keep in mind is model size generally relates to the performance. It's not always true. You can find very large models that perform very poorly, and you can find smaller ones that perform relatively well. But generally speaking, the larger models tend to perform better than the smaller models. And if you're running this on consumer hardware, you can GPU accelerate up to about a 30 billion parameter model on 24 gigs of VRAM. And then after that, you're pretty much always going to be in software mode. What is interesting, though, at least on the Apple side, is that the Apple processors, the M2 series, might be actually the right way to go for running large language models today, in the sense that they have full access to system memory, and they have the neural processor acceleration. And so they seem to get very good performance, and at the same time, allow loading very, very large models into memory. And so if you're looking at a model larger than a 30 billion parameter model, and you're only looking at running it and not tuning it, it may be a case that Apple might be the right architecture for you. On the right, you can see the performance of generative AI technologies over time on image generation, text generation, and speech generation. And you can see that generally around the 2021 to 2022 time period, they reached human baseline performance, which means they perform about as well as a human does on the various tests inside of like the superglue text generation test. Now, that's not to say that you can't write better text than them, but we're talking about baseline, human capability. And often when it fails, it's pretty obvious that it fails. But sometimes it's not when it comes to hallucinations. So this is an interesting example of a hallucination that Gilad created. He asked ChatGPT about the Strongtalk project and to describe the Strongtalk project. And then he asked it to provide sources to back up all the assertions it had made about this project. And these are the sources that it came up with. So you can see, it's got hyperlinks and subjects and authors, and it looks pretty authoritative, right? I mean, this looks like something that a researcher might produce when you ask them for their sources. They write up something like this. Well, there's a small problem with this. The small problem is that Strongtalk doesn't exist, and the sources don't exist. The authors are people, but they didn't write any of these things. And so the challenge with hallucinations is that they tend to be incredibly credible. And they look incredibly credible because the language models are really good at producing output that seems plausible, even if it's completely fabricated. And so you have to be very careful with what you do with language model output, because it can look as high quality as this and yet be completely incorrect. So I'm going to move on to some security concerns with generative AI technologies. One of the things that people have been talking quite a bit about is jailbreaking. So OpenAI has constantly been trying to restrict ChatGPT to make sure that it doesn't produce obscene output. It doesn't, do anything that could get them in legal trouble. It doesn't produce, legal guidance and purport to be a lawyer providing advice, all kinds of things like that. And a lot of users, of course, want to make the ChatGPT system act like a lawyer or act like a certain person or produce certain types of content. And so they attempt to jailbreak it and get it to be unrestricted by the constraints that OpenAI has attempted to put on it. And on the left is an example of a prompt used to jailbreak ChatGPT and get it to produce output that would otherwise be restricted. And the reason this works is that largely ChatGPT's security around producing content they don't want it to produce relies on tuning of the language model to bias it away from certain types of responses, and some level of filtering of input and output. And the challenge with this approach is that, as I mentioned before, the tuning of the model, if it hasn't been completely pruned of certain concepts, it doesn't really stop it from producing that output. It only makes it less likely. And given the right prompt, you can bias it back towards producing the output that the trainers tried to train it against. And the problem with the filtering approach is that the input and output are unstructured text. And unstructured text is very hard to filter against generic sort of general scenarios like offensiveness. And even worse, their filter seems to be sort of a few words at a time kind of filtering, rather than buffer the entire output of the system, apply a filter, and then send it on. And so if you tell it to talk like a sailor, it will talk like a sailor, because talk like a sailor is not a phrase that their filter knows about. It is a phrase that their language model knows about, and it will bias the AI to talk like a sailor, so to speak. And then offensive content can now be produced by it. And often that will leak through their output filter before they catch it and try to sort of correct it and say, oh, ignore what I just said. But attacks actually can take a lot of different forms. There's attacks on different environments using AI to accelerate those attacks. So this would be using like ChatGPT to develop attack tool chains and using those to attack a website or some system. And there's an effect called democratization of attacks, which is that because ChatGPT can be used to generate attack code, it kind of raises every attacker's capability in generating sophisticated attacks. So now I would expect to see fewer sort of naive attacks and more attacks that use polymorphic code, use steganography for exfiltrating data and things like that. Similarly, it can be used for source code analysis. And so it can be used to discover vulnerabilities in a code base or perform a threat surface analysis. And finally, and this is one that people have already started hearing about in the news, is AI-generated phishing attacks. So with the ability to create text that sounds like it comes from a person, speech that sounds like it comes from a person, photos of that person in various scenarios, social engineering attacks are going to be unfortunately rampant. Now looking instead though at attacks on the model itself, you have several different types of attacks. You've got poisoning attacks, and this would be where someone attempts to poison the training data. So we know that OpenAI draws from Reddit, for instance, to source some data for training. So you could create a series of posts on Reddit that, if consumed by their system for training, teaches it the wrong things. So that would be an example of a poisoning attack. You have evasion attacks. So this is largely just the typical cat and mouse game between attackers and AI defenders related to classification and changing what the attack looks like to bypass a previously trained classifier. You have model extraction attacks. So the model has been trained on a certain set of data, and given the right prompts, you may be able to extract an example of that training data set from the model. And so you might set temperature all the way down to 0, so it generates the most likely result. Feed it parts of the output that you want and see if it will auto-complete them. And then you keep doing that over and over again until you finally get the original input back out of the system. And finally, prompt injection attacks. And this is injecting malicious data directly into a prompt or a side channel to compromise the system. And I have an example of that later. But given all this, defenders are going to need to adapt to this changing security landscape. And I think that technologies like SSL Orchestrator and those used by the CASB space will end up playing a critical role in this kind of security, because it's critical that you catch interactions with these machine learning systems. Often they're encrypted, so break and inspect technologies are key. And things like CASB are required for monitoring user access to systems and seeing what they upload and catching data exfiltration and the like. So this is an example of a prompt injection attack against an augmented language model, which I think is the much more interesting case. The diagram on the right is a diagram of AutoGPT. And in AutoGPT, it's not just the straightforward prompt sent to a language model, but rather code can be executed. And the way that might work is that a prompt is sent to the language model. The language model then generates code. The code is then run. The output of that code is fed back into the language model, and then that's to produce a response. Well, if you can imagine a scenario where AutoGPT is retrieving content from the internet and it's downloading images and it's pulling out EXIF data, and someone has poisoned that EXIF data to include prompt information, that prompt information may get fed into the input that is used to generate code. And now there's potentially an attack vector for getting it to generate malicious code that would execute in the environment that's this language model. And that could be used to further compromise the system. And unfortunately, the industry is not really focused on security today. And you can see that in the code and the models that are being developed. There are a massive number of potential attacks against these systems. Largely, there's been very little effort in the open source community at closing these kinds of holes. So what are some of the opportunities? Well, on the right, you can see in a number of different domains, some of the things that the rest of the industry is exploring, right? So in the text generation space, you've got marketing content generation, sales email generation, support generation, general writing, note-taking, et cetera, right? In the code side, you can generate, text to SQL and web app builders and code generation. The space is really limited only by your imagination. And maybe the technology for what you want to do isn't here today. But what you can accomplish today is actually incredible with what's already available in open source Python packages and even the language models you can download and run or using OpenAI. And you can easily automate tasks and processes, create high quality content at scale. And the key thing though is to be careful about hallucinations, potential bias, any ethical concerns around what it is that your tool will achieve. And you need to be aware that when output is generated, there's no easy way to get a clear source for the output. Even in scenarios where in Bing, they purport to give you the sources for the responses. The reality is that those sources are the data the augmented language model augmented your prompt with. That's not actually the same as a source. The concept of a source for an author is I used these documents to produce the output that I created, and this is where I drew my facts from. That's different from saying, these are the documents I gave to another writer, and this is what they wrote back to me, right? It's missing the actual linkage between the documents and what was sent back, saying that these documents are the source of truth for the assertions inside of the output. And so even systems today that claim to provide sources, they don't really provide sources. What they do is they provide the list of supplemental input that was used. And so you have to be careful about even systems outputs that purport to give you, the source of their information. And finally, of course, this is still incredibly resource intensive and computationally expensive, particularly if you want to get into training. There are advances on the local model side with things like LoRa generation, which allow you to avoid having to do a full training of an entire model. But if you want to do training for an entire model, this is a massively computationally expensive task today. So looking at where this technology can be applied across a customer's application lifecycle. So this is sort of like an F5, product development perspective on where could we influence our customer experience across our customers' apps lifecycle? Well, we could do application modeling, security posture analysis, policy creation, I-rule generation, policy deployment error analysis, root cause analysis. All of these are great uses for generative AI. Now, those are the boxes I colored in purple. The other ones you might be able to do with generative AI, but you should think about whether or not your approach is the right approach in terms of efficiently using resources, or whether a different machine learning or AI technology would be better suited. So, for instance, AI-based auto-scaling. This kind of a task, from my perspective, doesn't really need deep learning and generative AI. It can be largely solved by much simpler AI technologies and at massively lower cost, both computationally and from a development perspective. So as you are looking at your projects and working on your solutions, think about exactly what you're doing and is this a fit for generative AI or not. My brief scanning of the project pages for Greenhouse, they all look like great projects. But that's just something to keep in mind. So in closing, generative AI is absolutely a revolution. The landscape is changing literally daily. GPT was released in mid-2018. GPT-4 was released March 14th, 2023, and the performance difference between those two is astounding. Open source packages are rapidly evolving, so largely you're probably going to be working in Python, and daily I find updates to packages I've been using or new packages that I'm interested in using and I have to put on my backlog of things to explore. And the Llama models are also rapidly evolving. So if you're using a Llama model and something like Llama CPP to run it, or one of the other engines, those are also evolving incredibly rapidly. So this is going to upset the industry, the generative AI technologies, and it does pose a major risk for F5, but also opportunities. And I'm really excited about programs like Greenhouse because it allows us to really pursue those opportunities and get ahead of the curve and take advantage of all of this disruption. And I'm really excited to see all the projects that you guys work on. And if you want to talk to me about your project, I would love to hear about it. Thank you.
Thanks, Saxon. So we have quite a few questions in the chat.
Sure. Let's see.
And if you wouldn't mind, stop sharing your screen.
Sure, I can stop sharing.
Thanks. So first question we have is, what generative AIs are supported by F5? Do we need to utilize specific AIs for our work integrations?
And to my knowledge, the only one that is supported today is our OpenAI, and only for the purposes of ideation and for the purposes of, like, as a search engine, trying to ask it questions like you would a search engine. And then, of course, with the restrictions that you're not allowed to send any proprietary F5 information, PII, et cetera, into the system.
The one thing we can add there is that this is, I think Saxon mentioned it, there's a lot of work in progress in coming up with safe sandboxes that F5 Legal has approved for F5 related work, but we're not there yet. And therefore, this month, you may have seen in chat, we are inspiring F5ers to come up with ideas, understand the technology and come up with ideas, but not really try to do POCs with F5 information. Just hold your horses on that. Proper sandboxes are being put together.
Yeah, and there's another question related to what you just said, Mudit and Saxon. So to try using generative AI, we really need to be able to input a lot of internal information. How can we get access to something where we could do that? Like Mudit mentioned, we have a few sandboxes in the making by experts across F5, and so more to come on that in the weeks to follow. We have a question. When will F5 teams be allowed to use Copilot in our IDEs, please?
Same answer. There is a team that is reviewing use of Copilot technically to see how useful it is and how accurate it is. And F5 legal and security teams are figuring out, the legal aspects and practices for safe use. So again, we need to hold our horses on that one. More to come there. So there's active investigation of Copilot going on.
Yep, and same answer applies. There was a question asked, are we planning to acquire a corporate license for GPT-4? So same answer applies there. We have a question. What is considered an upload? Asking GPT a question?
Yes, anytime you send any data to one of these services in any form, so use of their API, using the chat interface to ask a question, any way that you send information to them would count. Yeah, basically everything you send to them in any form counts.
Okay, thank you. And how can ChatGPT do a linear projection based on pattern matching of tokens? It's hard to see how that can lead to completing calculations.
So for tasks like that, one of the approaches I've seen is getting ChatGPT to generate code that will perform a linear calculation and then executing that code, and then taking the output of that execution and feeding it back into ChatGPT, which then uses that as an enhanced prompt to tell you about the projection. In other words, it is not the language model itself that does things like a linear projection. It's other things. Now, in the example I gave you, it just decided to do some form of a linear projection, which is kind of surprising. And it seemed to be accurate in terms of it was in fact linear. But usually when people try to ask it math questions or calculation questions, the most successful approaches that I've seen tend to be not using it to perform the calculation, but using external augmenting systems to actually perform the calculations.
Thanks, Saxon. There's a question on some content that you presented. So is low temperature setting reducing the hallucinations?
No, low temperature does not reduce hallucinations. Low temperature means that the output is going to be the more likely output based on the frequencies of things that the system was trained on. In other words, it's sort of like less random, you might say, but that doesn't mean necessarily less hallucination.
Okay, and Saxon, as I understand that ChatGPT is just trying to predict just next token with probability, then how does it perform it in correct context, and how does it decide to start generating the answer?
Well, it has everything that you've said to it as context. And so it's using that and then continuing on from whatever you prompted it with. And for systems like ChatGPT, there may have been augmentation by the chat interface itself. Like often those systems say that they add notes about the text is from you, the user, to separate that from the concept of text from ChatGPT returned back to you when they're looking at their history. So there's additionally other information that's likely annotating what you've written. But in the beginning, in your first message, it's very little annotation because there's not much to add. But it's really kind of predicting on from that question. And so it's very, very critical that you actually put what you want in that question to steer it in the right way, because you are literally steering it.
Thank you. These are great questions, so keep them coming. We have one here. So re-code generation. Are there characteristics of programming languages that influence quality of generated outcomes? I'm wondering if languages that use syntax similar to English language, think Python, have better generated outcomes than others like C, C++.
I would say yes, there absolutely are. So one example, and it's not necessarily a language characteristic, but it is kind of associated with various languages, is the way that variables and functions are named and how they show up inside the text. Those can have a massive influence on the ability for a system to understand what your code does. So for example, you could take all the source code for OpenSSL, and you could rename every variable and function to make the entire thing look like an image editing tool, right? Just by changing all the names of every function and every variable, okay? But leaving literally all the code the same. So it's still OpenSSL. If you were to feed that into something like ChatGPT or Copilot and ask it, what does this stuff do? It will very likely give you responses related to image manipulation. And the reason is because it doesn't really understand what you're doing. It understands a lot of the terms as well, and those are going to steer it in the wrong direction. And so we were kind of lucky in the case with iRules, where we had a text-based language with very clear variables and functions, with documentation online, with comments interspersed with those things. And as a result, it's pretty good at generating correct tickle code for iRules. But if you instead asked it to try to generate congestion control code for the Linux kernel, it will do a very poor job because there tends not to be good comments on it. The why behind that code is not clearly explained inside the code. It will generate some code, but it's not very useful at helping you in that kind of a coding task.
Thank you. We have a couple more questions. So can F5 support use AI to take a QK view and produce a root cause analysis? Do we have the answer to this, or do we need to clear this with compliance and other folks?
I would say that please submit that as an idea in the Idea Fest. It requires a lot of thought about how you would go about doing it. So it's, there's a month-long time period when we can take ideas like these and clarify them such that, by the time our sandboxes are ready, we can try to test some of these things. So the suggestion would be, please submit it, and then let's work on it, clarifying it. Thank you for sharing it here.
And we have one more question I see. Has anyone trained a model here at F5 yet? Do we have a knowledge base or an index of repos namespace for AI related work experiments?
I believe the Shape team was looking at training a model for understanding the DEX programming language. So I believe the answer to the first part is at least yes. People have trained models here at F5. But as to the second question, I don't know of a repo or namespace for AI projects. Maybe Mudit does.
Not at this point. I would say, not at this point, but it's a very good idea. We should create one. The best place that I know of is on the greenhouse side, with the Idea Fest page. That's the best place to connect with the community and see what kinds of thoughts people are having. But you just give us a good idea. We should have a nice repo, KBs, one page to describe it all, including sections presentation from today if people want to listen to it. So we will try to do that.
And to add to that, Mudit, we also have a session this upcoming Wednesday on example use cases using generative AI, led by experts across F5. So registration details for that session can be found on the Idea Fest page, and we'll continue to explore where we can gather all these findings in one place.
Daxon, thank you so much. That was excellent. Absolutely excellent.
Thank you.
Thank you. I'm going to be listening to this presentation again.
My pleasure.
Thank you so much for attending. So that wraps up our first session, and we look forward to having you in our future ones that we have scheduled for the upcoming weeks. Recording for this will be posted on the Idea Fest page. So be on the lookout for that. Once we receive it, we'll publish it and push that in. Thank you so much. Have a great day. Bye-bye.
Bye-bye. Thank you.